Okay, this is two variable stats notes day 2. And last time we found a line of best fit, or otherwise known as the least square regression line, using this horrible table and this horrible formula, and that was only for 3 points. This time we're going to use the calculator. I am going to show you on the video. We were going to do it in class, but we ran out of time. And so follow along if you have a calculator. Otherwise, just make sure you take notes. So what we need to do, okay, go ahead and turn your calculator on. We're going to go into Stat, Edit, just like we've done before, and list our X points, which were 1, 3, and 5. And then we'll go ahead and list our Y points, which were 3, 5, and 6 respectively. Okay, so now we want to hit Stat, Calculate, number 4, that's linear regression. And we had our variables in list 1, our Y variables in list 2. And right now I'm going to stop. We could go ahead and store our equation right here. We'll talk about that in class, but we won't do that right now. Instead, we'll hit Enter. And you can see our line of best fit is Y equals 0.75x plus 2.42, which was much easier than what we did here. Okay, I went ahead and wrote those directions down for you, so you can pause and write them down. Also, if you have an old calculator, at this point it won't give you this nice prompting. Instead, it'll come up and say linear regression, and you'll do L1 for your X's and L2's for your Y's. So again, 100 times easier than what we did with the table. You will only need to use the table if you're going to do this in your IA. Okay, so the next section, measuring correlation. Okay, so I left these vocabulary words in there for you, so let's just go over it. Correlation measures the strength of the linear relationship. Basically, how well all your little points fit your line. The better they fit, the stronger the strength. Okay? Pearson's correlation coefficient lies between -1 and 1, and that is R. Okay? A positive correlation is when the slope is greater than 0 or positive. Okay? And that means R ranges from 0 to 1. So here would be a perfect correlation. You can see that it would fit in a line. Here would be a fairly strong one, maybe moderate to strong. This still seems to have a positive slope, but there's more scatter. And then this, almost no correlation, just a little bit. Okay. A negative correlation is the same thing, but this time the slope of the line is less than 0. Okay, so your R ranges from 0 to -1. Same exact thing, just we have a negative. So let's say this equation was Y equals -x plus 10. Okay, notice that the slope was negative. And the reason I was able to write the equation is this is just a nice, easy, perfect line. So I could pick one, and this would have been 10. Okay. How do you find R? Well, bottom line is we'll use the calculator. But again, being IB, they want me to show you how to do it by hand, so let me show you. R, again called Pearson's correlation coefficient, can be found by S of xy divided by S of x and S of y. And they each have their own little formulas. S of x, which is called the covariance of x and y, can be found using these two formulas, either or. S of x is the standard deviation of all the x values. Okay, so it's our regular standard deviation formula. This one or this one, but we are really used to this one, so this is the one we would use. And then the same thing for S of y, the standard deviation of y, same formula. So once you had those pieces, S of x, S of y, and S of xy, you could just make this fraction. And the nice thing is usually IB will just say S of x equals this, S of y equals this, S of xy equals this, and you can make the fraction. If not, however, you could also put those pieces together and use either this formula or this formula. Okay, so let's talk about that. Here is an example using, looks like they're using this formula, okay? And we'll do this once, just in case you need it. A chemical fertilizer company wishes to determine the extent of correlation between the quantity of compound X used and lawn growth per day. Find Pearson's correlation coefficient between the two variables. So again, we have 4 data points, 1, 3, 2, 3, 5, 4, 6, and 5, 8. And what this means is, for example, for lawn A, they put 1 gram of maybe fertilizer on the lawn, and it grew 3 millimeters. Lawn B, they put 2 grams, and it also grew 3 millimeters. But by the time they got for lawn C, 4 grams, it grew 6 millimeters, okay? And we're trying to see if there is some type of correlation. The more of this compound, the more of this fertilizer, the more your lawn will grow, okay? And they're actually, in the real world, it would probably do something like this. It starts out good, and then it's going to start to die if you do too much. Or maybe it would be an equation like this, where it's going to grow and then too much and you just burn and kill the grass. But this is made up for IB. So again, just like last time when we had the table, list all your X's. Okay, and then you add them up. List all your Y's. Whoops, that is not a Y. List all your Y's and add them up. Okay, X and Y, that was times. So 1 times 3 is 3. X squared, Y squared. It's exactly what it seems like. Okay, so that we can find all of these data points. So the sum of X is 12. That means added up the X's. The sum of the Y's was 20. I added up the Y's. The sum of the X times Y's, that was 73. Sum of the X squared, now it literally is 2 squared, which is 4, and then you add them all up. Okay, let's pick a different color for that one. That was 46, and then we had the Y squareds as well. And what they have you do is just fill in the formula. So the formula from right here says the sum of X and Y, so 73. Well, and you know, I'm just going to let you guys know. Okay, so they said the sum of X and Y, which was 73, minus N. So let's see if we can work backwards on this formula. Hold on, let's do this. R equals, well, 73 must have been the sum of X and Y minus, well, N was 4. So 4. So anyway, we had the sum of X and Y minus N. And then if we look 12 over 4, that must be the sum of X all over N. And it looks like the sum of Y over N, maybe? Let's go back and look at our formula and see how we did. Oh, well, look at that. It's actually supposed to be X bar, Y bar. Well, that makes sense, though, because the sum of X is X bar. The sum of X divided by N is X bar. And the sum of Y divided by N is Y bar. Anyway, I'm sure that you guys could take this formula and plug everything in, okay? And you would get R. Well, what does an R of about 0.969 mean? It means that if we were to draw the line of best fit, it would be positive. Okay, and I'm not exactly sure what the line of best fit is here. I would have to find it. Okay, which means as they add chemical, they expect the growth to increase. Okay, and it's a pretty good fit. So maybe 1 or 2 grams of chemical wasn't enough to do anything, but then after a while, it started growing. And I'd be curious to see what would happen after 7, 8, or 9 grams of chemical. I think you would at some point start killing the grass. Okay, but that's how you do it by hand. Again, nobody would want to do that. So let's look at this real quick. In attempting to find if there's any association between average speed in the metropolitan area and age of drivers, a device was fitted to the cars of drivers of different ages. The results are the following scatter plot. Notice that it has a positive 0.027. Well, does that mean that there's a positive slope here? No. What that means is R is almost 0, so I would say that there's basically no association. Okay, so the average speed and the age of drivers, you've got, which is kind of weird. You think that old drivers tend to drive slower, okay? But according to this data, not so much. All right, the last part, coefficient and rule of thumb. I am going to pause and do this on another video.